When we look at this, you automatically know that you can't just use GCF to factor. There has to be something else. What do we do? Okay. A lot of times when we think that an expression or polynomial is prime, it may not be completely prime. It may be have to factor it a different way. Okay. The first way that we're going to learn is called simple trinomial. Simple trinomial means that your leading coefficient, is a 1. So it doesn't have any bearings and it doesn't make things difficult. Okay. What I'm going to teach you, I call the branch method. Okay. So we're going to talk about the branch method. The branch method is pretty straightforward, and hopefully you guys are okay with it. If you have a composition notebook, this is just a little tidbit, and you struggle with the multiplication chart, most composition notebooks, like old school composition notebooks, has the multiplication chart in the back of it. So if you're a person that struggles with multiplication, just saying, there's a little extra in the back of your notebook. Khalil, I'm up from the internet. And you know why. Close the laptop. Can you let Eminem please? All right, so on page 77, in our first box, we're going to write b squared plus 7b plus 12. Now, when we look at this in terms of greatest common factor, we're like, well, there's no greatest common factor, correct? They have nothing in common, okay? B squared plus 7b plus 12. You're like, they have nothing in common. All right, this is me wishful thinking. Back in Algebra 1, did you guys learn how to factor simple trinomials? Okay, I also went to a different school. So he said yes. We got one yes. Anyone that was in Waco ISD remembers how to do a simple trinomial? No? Okay. All right. Here we go. Without a calculator. Because that's the key. That's the key here. All right. It is very simple. All you need to do is know how to multiply and how to add. And you can factor a simple trinomial. All right. So you're going to look at your C term. Your C term is your constant term. And you're going to list out all the multiples of your C term. Okay. So my C term is 12. What multiplies to give me 12, right? That would be 1 and 12. That would be 2 and 6. That would be 3 and 4. Agreed? All right. After you've listed out those factors, you're then going to decide out of those factors, which one will add to give me my B term, which is my linear term, okay? Which is your middle, your linear term, because it has only one power, but to give me my linear term. So out of these options, which combination of numbers will add to give me 7? 3 and 4. Winner, winner, chicken dinner, okay? 3 times 4 is 12. And 3 plus 4 is 7. So my factors would be b plus 3 and b plus 7. And now we have factor. What we thought was prime was actually not. It just had to be factored a different way. Terrible? Doable. Doable, right? We just need to know our multiplication factors. We okay? Questions? We're going to try again. Huh? So whatever magic numbers work for the branches, that's what the factors are going to be. Okay? You know, with b plus 3 and b plus 7. Yes. Yes. Oh, not 7. You meant 4? How did I end up with 7? That's the question.
Oh, it looks like a 7.
It should have been a 4. All right. Now, what's the opposite of factoring? What's the word? Opposite of factoring is distributing, multiple distribution in this case. If you were like, oh man, I'm not sure if I got this right, guess what you should do? Distribute. When you're distributing with binomials, does anyone remember what that's called? You're going to check yourself using, does that ring a bell? FOIL? Yes? No? Maybe so? First, outer, inner, last. So checking myself. First to first. First term times first term. B times B is B squared. Outside terms. B times 4 is 4B. Inside terms, 3 times B is 3B. And your last terms, 3 times 4 is 12. And then you combine your middle. And if it comes back to what you started with, what does that tell you you did? You're a genius. You did it correct. Okay? In this instant, you're not being a genius by reopening that laptop. Close it. Temptation. Yeah. All right. Okay. Are you ready to try? Here's yours. Here's yours to do in the box. I believe in you. In your box, you're going to write down t squared plus 12t plus 35. Step 1 is to start with your C term. That's not bad. That was nice. Exactly. Even though that wouldn't have made a difference. Here we go. So starting off with 35, right? What are the factors of 35? 1 and 35 in. And that's it, right? I don't know where that line came from. My pen, she does weird things.
7 and 5.
Yeah. 7 times 5. All right, out of your two options here, which one will add to give you 12?
7.
7 and 5. So checking your branches. 7 times 5 is 35. 7 plus 5 is 12. I'm a genius, so my factors are t plus 7 and t plus 5. Okay? If I wasn't sure about myself, I'm like, oh man, I'm not sure if I got that right. Miss, no, don't call me. Check yourself, okay? I'm going to review another method that you may have learned how to check yourself. It's called the box method. So if you are not a foiler, you may be a boxer. With the box method, your values are on the outside and you're multiplying kind of like in biology class. T times T is T squared. T times 7 is 7T. T times 5 is 5T. And 5 times 7 is 35. You're going to always add like terms. So your output is T squared plus 12T plus 35. Okay. So I've now reviewed very much algebra. All right. So examples 1 and 2 are when you have all positive terms. When you're not dealing with positive terms, that means that you're now going to also have negative, right? So for example, here, and the last one that we're going to do, well, we're going to go on to the next part. We have z squared plus 5z minus 24. What that's going to do is the fact that you have a negative and a positive, that means that you're going to have what? A negative and positive factor, right? To make negative 24. So when you're listing out your factors for your negative 24 or thinking about them, you do not have to physically list if you're like good at doing it in your head. But you have to think about, okay, I have 1 and negative 24, or I have negative 1 and positive 24, right? I have 2 and negative 12, or I have negative 2 and positive 12. I have 3 and negative 8, or I have negative 3 and positive 8. Because all of these will still make negative 24. Does that make sense? Okay. And last but not least, we have 4 and 6. We have 4 and negative 6, or we have negative 4 and positive 6. So you have 8 possibilities that satisfy negative 24, right? So then you're going to look at your B term, your linear term, and ask, out of these possibilities, what combination of numbers will add to give you a positive 5? So which combination of numbers would be my winner? I need a positive 5. So which pair gives me positive 5? What kind of 3 and 8? I need a positive 5. So my 8 would need to be Positive. So it would be -3 and +8. Does that make sense? So it would have to be -3 and +8 in order for that to work. Double checking that I'm not crazy. -3 times 8 is -24. -3 plus 8. If I have -$dollars in my bank account, I deposit $8. I'm left with $5. Whoopity whoop. That correct. So therefore, my factors would be -3 and +8. And that would be my factored form. Yes. Are you with me? All right. So when you have the negative, you're going to have to pay attention to which combination you're using. All right. So if we have a positive and a negative, that means I'm going to have one positive and one negative. If I have a negative and a positive, that means I have to have two negatives. And the reason being is the only way for a product to be positive with a negative is they both have to be negative, because a negative and a negative makes a positive. You can't make a plus sign without two lines. Okay. So you have to have that negative, and that negative is going to make a positive. Throwing this in there just to remind y'all. Did your teacher do the tic-tac-toe 3 in a row to remember when multiplying and adding negative? So tic-tac-toe 3 in a row.
Yeah.
The goal of tic-tac-toe is always to get 3 in a row. So what this represents, if I have a negative, a positive times a negative is going to be a negative. A negative times a positive is going to be a negative. And a negative times a negative makes a positive. No matter which way on this tic-tac-toe board I go, it's going to always tell me for product and quotient whether it's going to be positive or negative. Make sense? Okay. All right. On to what box are we in now? 4. Okay. In box number 4, we have 2x squared minus 18x plus 28. What's happening here is we're combining what we did on 76 with what we just did on 77. That's because before you can just start simple factoring, binomial factoring, you're going to always check for a GCF. So when we look here, is there a GCF? There is. What is the GCF? 2. So before we get started, we're going to factor out our GCF. So we're going to divide everybody by 2. Agree? So that means 2 GCF goes on the outside, and our quotient is x squared minus 9x plus 14. Okay, now I have a leading coefficient of 1. So I'm asking myself what multiplies to give me 14, but adds to give me -9. So what combination of numbers will multiply to give me 14, but add to give me -9? So yourself, you're thinking, what makes 14 a positive 14, but need a negative number? That means that they both have to be negative, right? -1, -14, -2, -7. Out of these two options, which one makes -9? -2 plus -7 is the winner. Okay, so when you write your factor, you're going to still include your GCF, doesn't disappear. So we have 2, then we have x minus 2, and we have x minus 7. If I'm not sure about my answer, what do I need to do? Check. I check by distributing. When you're distributing, you're going to do your FOIL, your binomial multiplication first, and then distribute your GCF. You go back in the backwards the order you came. Does that make sense? What square? Because we distribute. X times x is going to reproduce itself. Remember, factoring this says breaking things down. So our factored form would be 2 times x minus 2 times x minus 7. All right. Are you ready for your example? Here you go. I'm going to give you a couple minutes to do. Here's yours. You have 3x squared plus 6x minus 9. See how we did, little geniuses? All right. So up first, always check for a GCF when your leading coefficient is in a 1. So our leading coefficient isn't a 1. So our GCF we see is 3. So you factored out your 3, and you're left with x squared plus 2x minus 3. Next, you're asking yourself what multiplies to give you negative 3, but adds to give you positive 2. And what'd you come up with? Negative 1 and a positive 3. Good job. So you have 3, and you have x plus 3, and x minus 1. So your factored form should be this guy. And that's because 3 minus 1 equals 2, which is our B. And 3 times negative 1 equals negative 3, which is our C. And those are the numbers we needed to satisfy. Yes? All right, the last one we're going to do together, and then you're going to do a little note exit ticket, and then that's for the rest of the period. All right, so up first, notice here how we have a negative in front. And what do we say when we were talking about GCF? If your leading coefficient is negative, that automatically makes your what? Your GCF negative, okay? Our leading coefficient is negative, so therefore our GCF is going to be negative. Our GCF in this case is not a number, but a variable. It's negative x, and that's because every term has at least how many x's? 1. So our GCF is negative x. So we factor out the negative x, and now we're left with what's x cubed divided by x? 3 minus 1 is? 3 minus 1 is 2. So you're left with x squared. Negative 3 divided by negative 1x is going to leave us with a negative 3x. Negative, positive 3. Positive 10 divided by negative x is going to leave us with a negative 10. So notice when you divide out a negative, it's going to change the signs of everything. Do we see that? All right, so now we're asking ourselves, what multiplies to give me negative 10, but will add to give me negative 3? So what two numbers multiply to give me negative 10, but add to give me negative 3? Perfect. Positive 2 and a negative 5. 2 times negative 5 is negative 10. And 2 plus negative 5 is negative 3. Your GCF is still going to stay part of your solution. And then your factors come from your numbers that make it work. So we have x plus 2, and we have x minus 5. And it does not matter the order you write them in. What matters is the signs that they are. And if I wasn't sure about what I did, what should I do? Distribute. Distribute and check myself.